Geometry and construction problem number 88 from Unit 1. It says given this scale factor, 3/4 of an inch equals 1 foot. So in the model, 3/4 of an inch is paired up with, I know it says equals, right? Is paired up with this 1 foot. Okay, that establishes our scale factor. So find the scale size of a bedroom that measures 10 feet by 12 feet. So this is the house size, the feet part, right? So I'm going to put this, now we're going to have to do one at a time. I know you want to do both. I know you're tempted to go 10, 12, right? That's not going to work. Okay, we had to put the house and the denominator matching up. And we're going to solve for this. Okay, now I can cross multiply 10 times 3/4 divided by 1 equals, and that will give this to me. But I just noticed right here that 1 foot to 10 feet, right? If I just do times 10, that means I can do times 10 up here. So I'm going to do 3/4 of an inch times 10. Now when I multiply, I have to put it over, if it's a whole number, I put it over 1. And then we multiply straight across. So I can do 3 times 10, which is 30. 4 times 1, which is 4. And so I get 30 over 4, and then I can simplify that because these are both even numbers. I can put 2 into both of these, so I end up with 15 over 4. Now, this is an ugly way to write a fraction, and so you need to say, well, let's write this as a mixed number, right, as a whole number and a fraction. The way that you do that is you'd say, I'm going to take this bottom number, this denominator, and how many times does it go into 15? I know it can go into 15. Well, 4 times would be 16, so that doesn't work. So 3 times, it can go in there 3 times. 4 times 3 is 12, right? So 3, it can go in there 3 full times, which would be 12. 12 fourths is 3. Okay, so that's what I'm thinking right here. 12 fourths is the same thing as 3. Well, if I take 12 of those fourths out as 3 whole, right? How many fourths do I have left over? 12, 13, 14, 15. 3 fourths. So 3 and 3/4 is the same thing as 15 fourths. 3 and 3/4 inches. Okay. Now let's take a look at the next one here. Okay, instead of 10 feet, it's the same setup, 3/4 inch to 1 foot. X inches to, this time it's 12 feet. Okay, and I can do the same thing. When I see an easy multiplication problem for one, I can just do the same thing for the other. 3/4 times, this is times 12, so this would be also times 12. So I'm going to do the same thing, 3/4 times 12 over 1. Now, this time before I multiply, and I could have done the same thing up here, but I wanted to show this to you separately. Before I multiply, if I see a number in the denominator, even if it's in the other fraction, now this works multiplying. This does not happen when you're adding or subtracting. That's a different set of rules, right? But when you're multiplying, if you see a number in the denominator that can be canceled out with a number in the numerator, you can do that beforehand. Okay? So let's think about what happens here. Oops, 3/4. Let me scroll down just a little bit. So 3/4. So I can say, well, 4 goes into 4 1 time, and 4 goes into 12 3 times. So I divided both of those by 4. So I get 3 over 1 times 3 over 1, which is 9 over 1, or just 9 inches. Now, if I hadn't have seen that, I still would have gotten the same answer, 3/4 times 12 over 1. If I wouldn't have noticed the cancellation there, 3 times 12 is 36 over 4. And then I could have canceled here. 4 goes into 4 once, 4 goes into 36 9 times. I still get 9 over 1, which is 9. Okay? All right, well, there is problem number 88. We have another, it says, what is another way to express the dilation of the bedroom? Okay? Well, it's, right, 3/4 to 1 foot, 3/4 of an inch to 1 foot. Another way that you can express this is just asking yourself, how many times bigger is it? Okay? Now, I'm going to show this to you, but you do not need to do this. 3/4 of an inch, 3/4 times something equals this 1 foot, and I'm going to write it this time. This time I'm going to put it in the same unit, so I'm going to put it in inches, so 12 inches. 3/4 times something equals 12, right? 12 over 1. So I could just divide 12 divided by 3/4. I could also say, well, I'm going to say what would I multiply here to get this. Some of you can figure that out in your heads pretty quickly. I can also say times x, right? 3/4 x if I want to switch to algebra. Okay, I can do that. And if I do that, I can say to get rid of this 3/4, I multiply by the reciprocal. Okay, so if I do that, if I go that route, I get x on this side because those cancel. And this side, 12 times 4 is 48 over 3. I think 48 over 3, that should come out evenly. I think 3 does go into 48. I think it's 16 times. 48. Can that be divided by 3? It sure can. It's 16. So you could say, another way to express the dilation is you could say that the dilation is 16 times larger. Or you could say it's a 16th of the size, right? These are all ways that we can say the exact same thing. Notice when I write the 1 to 16, it's very similar to that ratio, 3/4 to 1. But notice this one, I don't have to put units because this is same units, different units, 3/4 of an inch to 1 foot. I would have to keep the units because it's not the same numerical representation. But if I switch it and it's the same units as 1 to 16, that means 1 inch goes with 16 inches, or 1 foot goes with 16 feet. Okay. All right, that was a long problem. Hopefully you understood that. If you have any questions, let me know.